Palumo is at 84D6B, and we're only at 86D6B. We're too low. We need to get up there. Up to 150. So let's go back to the other instruction we had. We need to find out what REX is. REX is 10. Get a calculator and see what 10 is. 16. Oh yeah, I need to point this out as well. REX and EAX. That's a that's between the 32, 64-bit registers that we're dealing with, and it's writing into the one that we want. That's a bit of a problem. If you ever come across something like that, the best approach is to just break and trace it. And hopefully you're not dealing with a value that you don't want. Okay, so you need to know what REX is before it is being written on. So let's go one step back. Seven. Because once it writes it in, it's B. And that's 11. That would be Great Jagras. Okay. So when I first, and this is connecting all these different elements, but monsters have IDs and Jagras would be 7. If I were to be correct about that, and I would have to pull up the website for this, because I don't have the list right now. Where the hell did I put that website? It's under one of my researches. The heck was this? No, that wasn't it. Where did I put it? I know I saved it. Let me see if my history shows up with it. Yeah, Great Jagras is number 7, but I'm trying to find Palumo. And I had it, and now I don't. Oh, 1F? That's the hex value. 131. Thanks. That'll work. So let's see if we get to that. We're going to keep that base offset plus 31 times 4. Should come up. Are you sure it was 31? That should have led us straight to it. Where did it lead us to? BC 54. We're way too far ahead. Well, correct me if I'm wrong, but we have to deal with hex. H6D6 BCOC. We're right, but why are we're too far in the 2000s here. How did that happen? Let me look back. We must have made a mistake somewhere. RCX is this offset. So to be sure that we are on the right track, get that save region. Let's see what kind of, we're at 86, but we should be at 84. So why are you leading us to this? Where am I making the mistake? Because it is 84. I'm making a logic mistake and I'm not sure why. Let me see what that does. I think I know what I'm doing wrong. Because now we're here. Plus 27. Maybe 110. Well, now it's right. Okay. Now it is correct. So maybe I screwed something up in here. Let me double check. Yeah, there's another 2 in there. That was my mistake. Sorry about that. I just put an accident typo in here. Now we're on the correct track. Okay, so 1F times 4, and then the save region. So here is our pointer for Pao Lumo. And like Asterisk said, if you leave this area, the address that we found for this is going to be blank. In my case, it would not be blank because this is actually in the save region, and the save region doesn't change. It's a poor example, unfortunately. We just got unlucky here. Unfortunately, the game accessed the save region consistently. But anyway, we did find the pointer to our lures in a matter of a few minutes here, using the same method that I just showed you from all the other functions we did. So in this case, we need to find something where it's more difficult to find a pointer, and I think I have a good example of this. Let me see. Timers. That's either that or health of monsters is a good example of that because they constantly change. Let's see if we can find something that's. I hate Ancient Forest but it's not raining, so we'll take it. Okay. We remember that we were able to access all actors' health. So we're going to go ahead and use that as a shortcut. It was the first one, I believe, that had all the results. Nope, was the second one then. Yeah, here we go. And the monsters are going to be this one, and this one. Because everything else is either you, which happens to be here, or these poor little small monsters. Okay, so out of these 3, one of them, let's set this monster to 5. It should start limping around like a little baby. Question is which one of it was. It may have been Kuluiako or Tobi Kadachi. But Monster Pointers is a perfect example of what changes every time you leave and join the map. Are there any tracks to these 2 guys, or are they just missing? Pretty sure it was Kulu that I just edited anyway. Kulu has the Yoast health. Why are we here? Okay. Yep, it was Kulu, and he's coming this way. Okay, so Kuluiako is going to go to sleep and heal himself. Let's find out what accesses this. Oh boy. We got a crap ton of results here, but like I said, all of them are on the offset of 64, which is good. So now we need to find out which one is suitable for just monsters. Because we don't want anything accessing ours. That's going to be this one right here. So let's go through each one. Our goal is only monsters. Find out what accesses it. Nope. Too many results. Can't use that one. Let's try another one. Find out what accesses it. Too many results. Try the next one. Still too many results. Try the next one. Oop. I meant to click that, sorry. Nope. Still a nope. Still a nope. Oh, we got still a few left, so chances are we'll get lucky. Nope. Nope. Are we that unlucky? There we go. So here are the three monsters. We want this one. This one's very important to us. Let's go ahead and add that to our list so we know that this is the... Alright, so let's look, before we start debugging on our offsets, we notice something. First offset is 64, REX is being written, and then REX gets modified here with RBX plus 7670. Since we already found health, let's see if this health leads to the monster that we're looking for. Chances are, no, it won't. Okay, so we know for a fact that it's not related to this section. We only know two offsets. We could probably backtrack it, but let's say it's too difficult and we're not sure which one it is. So we're going to take Kuliako's HP and generate a pointer. And wait for the... Did I do a pointer scan or did I do... No, I did the pointer map. Okay, so we just got to wait for the pointer map to go through. So we know 64 and we know that 7670 as the next offset. For monster. Now this is an interesting question. That means another level determines the monster type, because there's three monsters on the field. RBX, where's RBX? Here. Where's our results? Did we get rid of our results? Unfortunately, we probably did. Oh no, it's here. Let's find out what RBX is at this point. Let's break and trace here. Okay. Where is our instruction for the health? Apparently it's skipping. We don't want that, so let's break here. Set it to 1000. Alright, so let's have a look. Good, it's Kuliako with 171. RBX is 17 AC. Alright, let's see if we can scan for this address, see what kind of results we get. Oh yeah, there's a perfect example of the typical nope situation. We cannot use any of these because we have absolutely no clue which one's right. So I'm going to rely on that pointer scan for the moment and see if we get close enough to it. Looks like the pointer scan's done. So let's do a true pointer scan. Load up that pointer map. Put those two base addresses in there, 64 and what was that one? 7670. Let's go with 8000. And let's assume it's a 4. And hit OK. It's going pretty quick, so that's a good sign because we have two addresses, two offsets. Our results are pretty high, unfortunately. All right, let's see if we find an address that was close to these other addresses. Remember, we were looking for An address with 4CE 4150. So we're probably going to just look for this. Or something close to it. The 4D1s look pretty good. There's 44, 45, 46. Yeah, they're all kind of increasing. And the lowest, oh, I think the lowest is, here we go. So the lowest last offset appears to be, for this set, 1D40. It may seem that we have found an offset that's a little bit too difficult. So we're going to do the restart the game method and see if we get lucky to remove some of these invalid pointers. This is one of the ways you can reduce the results. Reattach the game once the game is fully loaded. If you load into too soon, it's not going to work. So once Capcom logo shows up, which it already did, so go ahead and hit in. And you'll notice the pointers we've already found, our health potion is 10 still. So that's a good sign. So is our Palumu result. Unfortunately, our health, stamina, and what was that second one? I think they were both stamina. Are not valid right now because we're not in the game. But we can get that fixed right away. And they should populate. And there we go. So yeah, we did a good job with that. Let's go back to the expedition and throw ourselves at Kuliaka one more time. Okay, so all these addresses. Now don't rescan just yet because you're not in the expedition for the monsters. These pointers are only valid when we're in an expedition. Okay, now some of them populated. First thing we're going to do is we're going to get rid of all the bad ones. Filter out invalid pointers. And make a new list. 15,000 results, not bad. So there's a couple in here that are negative, blah, blah, blah. Those are bad. This looks good. We have 4618. This could be Kuliako, for example. Our best option is to access that address one more time. Yes, we need to re-enable VH before we do that. Stupid debugger. Okay, stop. That's got to be Kuliako, Tobi Kadachi, and Rassos. Yes. Let's see. We were searching Kuliako. Now comes the programming logic. The Kuliako was in the first slot. The Kadachi was in the second, and Rassos was in the third. This is an array. So the first slot should be always Kuliako. And since we did this with Kuliako on the first scan attempt, we can go ahead and say the address we want to find is Kuliako. 16E76E5D4. Let's make sure we get that right, because if you get it wrong, you're going to end up with no results. And replace. Okay, now we're down to 10,000 results. Still not good enough. But, hey, look what we have. our noticeably addresses are here all of a sudden. So that's a good sign. But we want to find the other 3 monsters as well. So let's grab, this is pretty much a guessing game. Let's grab this one. And see if there's any chance that we come across. Probably not. Okay, so we have absolutely no idea about this structure. This is just Kuluyaku. Where is the other monster? That's what we need to find out. So let's go ahead and open this one more time. Let's find out. This was Tobi. No, this is Kuluyaku. Where's Tobi-Kadachi here? Let me put Tobi-Kadachi in sickness. Yes, you get disconnected because you modify information that you shouldn't be doing. Thanks, Capcom. And I have absolutely no tracking, but I am 99% sure that this is Tobi-Kadachi right now. Alright, let me just use a Raider. Get this over with. Go find me that Kadachi. Alright, while it's doing that, I'm actually surprised Kuluyaku's not there either. I have to find him again. Oh, there's Kuluyaku footprints. Got it. Yep, he has a skull. That was Tobi-Kadachi. That's good. All right, let's go ahead and pointer scan this. Well, better. Actually, we should do a generated pointer map on this guy first, just to be safe. And make it monster 2, because we know this is the second monster in the array. Basically what I'm trying to do is one of these offsets, it could be the second one, or it could be the very first one, changes depending on the monster. It's basically like a player selection. You could, in theory, switch over to another address and end up finding the health of player 2, player 3, and player 4. And this concept works with almost any video game that has multiplayer. First-person shooter games are basically the best way to do this. Alright, Tobi-Kadachi's healing. We're waiting on a pointer scanner. Fortunately, we still have over 11,000 results. Almost done. Let's go ahead and put Rassilus to sleep as well while we're at it, so he doesn't end up bumping into me. Yeah, he's got a skull on him now. There's a lot of people leaving and going. Pow. Pie. Alright, that pointer's done now. Let's scan it quickly. We know these two offsets have to be correct. we assume it's a 4. We're going to throw that map in here. And we're going to hit scan. I want to say Monster Hunter World. And we can't use Monster 1 and 2 again, so we're going to say second slot 1. They throw pie away because they don't eat everything. Okay, let's sort this to, oh God, here we go. I think we found something, a pattern. Here's a pattern. 4CEAA and another one 4CEAA. You'll notice the first offset changes. We're going to use this as an example. But you can do the same thing with this one as well. Did we even take? Yes, we did take a pointer. Let's use the one we originally had, actually. So that was Kuliaku. If my theory is correct, and this is an array, and it goes up, which is Tobi Kadachi for the next monster, the first offset should be bigger. But it's not. Yet it is bigger for the other one. So we do have to unfortunately use these two. Let's highlight this as Yaku, Tobi, and let's use basic theory. Offset E5A, ESOT. Take this first offset, throw it into the calculator, subtract it from the other first offset. So each monster is 50 off. Okay, so let's grab this one. That's the second monster. Open the calculator. Whoops. And add that number to it. No, not this number. The one I had in my memory, which you apparently didn't grab. Try it again. Plus. Okay, so Rathalos should be on this one. Are we right? Let's find out. EF8. Turn that into a float. Don't forget to turn that in the float. And yes, we are right. This is Rathalos. So we found the array for those three monsters. Monster 1, Monster 2, Monster 3. Of course, I named it Yaku, Tobi, and Rathalos because that's currently the map we have in here. But let's go ahead and test it. We're going to go to a different map, and we're going to kill them. These guys should freeze because we're no longer in the session. And let's go to Wildspire. Oh god, there's a... Oh wait, I'm not in high rank. Kuliaku again. But at least we have two monsters that are not the same. Let's see if they populate these addresses. Rogus. Let's name this Monster 1. Mon 2. Mon 3. Okay. Let's find out if I'm right or wrong. Monster 1 should be Kuliaku. Death. Kuliaku's gone. Let's see. Monster number 2 should be Bareth. Death to you too. He's dead. So we know that this is Diablos. Okay, so I did find the correct array and offset. And because we did that second scan, we can see what the offset was for this too. Now, why this one is larger versus this one is unknown to me. It could be that this is a completely different pointer that's being accessed by the game at a certain point. It is still valid though. But let's go ahead and rescan and remove all invalids in this one. And that was monsters 2 for the first one. We've got a whole lot less. We still have some significant results. So you can always keep them and then use them later when you restart the game next day and find out, okay, my pointers are not working, so I gotta update them. Alright guys, that's it for now. If you have any questions, go ahead and ask them. Yeah, it's you guys can talk now, or did you? Oh, Asterix probably has to unmute everything to allow people to talk. But yeah, it's very important to remember. You guys should, when you're doing pointer scans, find out what accesses that specific address, because the game will literally tell you what the offsets are, and then you're not blindlessly just scanning for everything. You guys can unmute yourselves now. Asterix just removed everything, so your permission should be possible. I mean, we could just move to Hall 1 if we have to.
That makes sense.
There
Thank
we
you
go.
I was waiting, like, where is everybody not unmuted?
I entered here like, okay, what that's going, like, hit talk, and you were like talking, and I'm like, oh, I'm guessing it's must be a class about your pointers. I'm like, okay, I'm not even gonna listen because I don't know what the fuck I would be doing.
Well, some people might still have trouble understanding exactly what pointers are, but pointers are basically nothing more than what the game is accessing, basically a shortcut to the specific value you're looking for. And it's sad because the pointer scans are literally addresses in the memory that just lead you to another address. That's all it is.
I get that point, but
when people... Yeah, go ahead. Like I said, but when you're searching for a pointer and you're just right-clicking it and saying, I want to scan for a pointer, you're going to be causing a whole load of pointers to show up. And that's going to include the temporary ones and the static ones, and then you've got the true ones mixed in. And you don't want that. So the only way to ensure you always get the true ones is to make sure you always find out what accesses that specific address, because it will dump out the offsets for you.
Gotcha.
And then when you're dealing with a nested pointer that leads to another pointer, you look at the base address, which will have one of the registers, like RCX. You scan that address, treat that address like you treated that value, scan for it, and then repeat the same process, find out what accesses it. And you'll eventually get to that result that you're looking for, that specific offset again. Like, this should be it, actually, if I did this correctly. Yeah, that was with the 7658.
Okay. As I was about to say, the only thing I know how to do in Cheat Engine is scan the hex numbers. That's the only thing I know how to do.
Yeah. I mean, there are some YouTube videos where they teach you about the pointers, but they leave out important facts about game instructions. They just say, yeah, just search for the value and then pointer scan it. And that's not a good way to do it.
Yeah, I would need you to teach me everything, and that would take probably a couple of hours. So not a good idea.
It's a lot of information to take in, but once you get pointers done, And Hello World's overlay mod is basically nothing more than that. It's a pointers list that he has stored in that program, and then the whole health bar of the monster or the buffs that you currently have is basically all he's doing.
Okay, gotcha.
Mm-hmm. Right. Right.
I
Good to
get
know.
that. Thanks. So I'm only doing hex scans. Yeah. Not that smart when it comes to cheat engine, really. And for me, thinking of a whole bunch of things at once does not work out well. I'm not very good at multitasking and be able to process a whole bunch of things all at once. That don't mix.
I mean, now that you've seen how I slowly got to the health and the monster health and the health potion pointer, you can tell how long it took to the point where my table is now.
Oh
I mean,
yeah, I can.
all these functions, all these pointer values.
Also, having to update the table on every update, right?
Well, see, that's where things get a lot easier. Once you understand and see the pointers, because the pointer address offsets normally don't change. What changes is the base address
Right.
every
right.
time it gets updated. So all you have to do is update the base address and problem solved. Now, if something like Iceborne comes out, a huge update, then yeah, the offsets kind of change, which happened with the first release before they did the fix. Everything was off by almost, I'm going to say, 30,000 bytes.
Yeah.
Good God.
But still, it was absolutely no challenge for me because I already knew the structure. And that's all it is, it's just a structure.
Marcus,
If I remember
you really
correctly.
you should really do your own YouTube channel. You really should make tutorials on doing cheat engine tables.
I mean, I see so many people doing it, that's kind of why I don't do it. But then again, I guess some people are having trouble following them to figure out how to do something.
This is very true. That's why I said it.
But yeah, thanks again so much for doing this. I wouldn't call myself a newbie at this, but even I was learning quite a few new tips and stuff. It's nice to see someone who's really experienced do this and see how they think about it and approach it. It's very useful.
And it's really interesting to find out how the overlay was done, Hello World, because it's basically the same thing. It's just pointers to those locations. Of course, like Asterix said, you have to make sure that you're in the right block of the memory.
Oh, you fuck up everything.
Yeah. But let me just boot up the Hello World on my screen for a second. I think, if I remember correctly, it tries to scan specifically for Monster Hunter World over and over until it's there.
And if I remember correctly, they just updated it today, correct?
Right. Because this is what he dumps out. Ah, crap, now I'm scanning everything. Oh well. I'll just copy this for now. If that works. Yeah, it does. Because this is what he dumps out, and you'll notice there's the block that he's scanning, the begin and the end. And then he's scanning a pattern. I'm guessing he's using an AOB, which is a convenient way of finding stuff. I use typically pointers because they are the shortest way to get to something I want to find. If I have to update it, I just got to change the address. An AOB is just, that's probably something I'll go in next time, using AOB and wildcards to find a specific location in the memory, because it's always going to be there. Which is a good example for, say, your inventory, maybe, or your part of your save data, which is what I used it for.
I'll be right back. Give me 3 minutes, Marcus. I'll be right back.
I find it easier to update an AOB for me